Welcome to Easy to Learn Technical Skills. Today I would like to explain about the concept of B-tree. B-tree are extended binary search tree specialized in M-way searching. B-tree is a self-balanced search tree. B-trees are multi-way trees. That is, each node contains the set of keys and pointers. A B-tree with 4 keys and 5 pointers represents the maximum size of the B-tree. B-trees are dynamic. That is, the height of the tree grows and contracts as records are added and deleted. In most of the other self-balanced search trees like AVL or black tree, to understand the use of B-tree, we must think of huge amount of data that cannot be fit into the main memory. When the number of keys is high, the data read is from the disk in the form of blocks, which disk access time is very high compared to the main memory access time. Main idea of using B-trees is to reduce the number of disk access, and most of the operation like search, insert, delete, min, max, etc. require O of h disk access, so the h is the height of the tree. B-tree is the fat tree. The tree will be increasing this fashion of left and right. It's like a breadth fashion. So B-tree is a fat tree. Height of the B-tree is kept low by putting maximum possible keys in the B-tree mode. So generally B-tree node size is kept equal to the disk block size since h is low for B-tree. Total disk access, most of the operations are reduced significantly compared to balanced search trees like AVL tree, red black tree. So there are few properties are there. Every node in a B tree will hold a maximum of m children and m-1 keys. Every node in a B tree except root node and leaf can hold at least m divided by 2 children. The root node must have no less than 2 children. All leaf nodes are in same level and maintain the sorted data. So these are the properties of B tree. Assuming that the order of m is equal to 4, we can have the m equal to 4 and the maximum keys are called 3. We can able to accommodate maximum of 3 keys and the minimum keys are 1, which means that m divided by 2 minus 1 is equal to 1. So 4 divided by 2 is equal to 2, 2 minus 1 is equal to 1. So this is a way we have minimum number of keys in the order of m, and maximum children is equal to 4 and the minimum children equal to 2. We can able to store minimum children are 2. So this is a way the tree will be constructed. Now we will see with the example. So if the order of m equal to 4, we can have 4 children and the key value is called 3. So this is the way the B tree will be constructed. So now I am going to take the order of m equal to 3. At maximum we can have 3 children and that maximum of we can have 2 keys. So this is called as order of m equal to 3. So 1, 2, 3. At maximum we can have 3 children and the key value is 1 block and 2 block. 2 key values we can able to store. So this is the way the order of m equal to 3 will work. So now I am going to take order of m equal to 3 and do the insertion operation. So here first I am going to insert number 50. So it will fill directly because there is no other values are there to compare. Then insert 60. So 50 will be compared with the 60. So 60 is larger, so it will come to the next of 50. So 60 will be placed here. Insert 55. So here 55 is coming inside the memory block, but there is no space to insert the value. So whenever we have the insertion operation, the data is inserted into the tree using binary search insertion, and once the key is reached the maximum number, the node is split into two halves, which means that, so here 50, 55 and 60. So here, so the node is splitted into two halves and the median key become the internal node when the left and right keys. So here 55 is going to become the median node, that means intermediate node, and the 50 will be placed in the left hand side of 55 and 60 will be placed in the right hand side of 55. And the intermediate node is called as 55, left hand side of 55 is called as 50 and the right hand side of 55 is called as 60. And this is the way the tree will be divided into two and the median value going to become the intermediate value. So now I am going to insert number 10. So 10 will be compared with the root. So here 55 is larger, 10 is lesser. So come to the left hand side branch. In this left hand side branch, you have to have the value called as 50. So now the 50 will be compared with the 10. So here the 10 is lesser, so it will present in the left hand side of 50. So after the insertion of 10, the 10 will be placed at first and 50 will be placed at next. And 55 compared to 55, the lesser values are there in the left hand side and compared to 55, greater values are present in the right hand side. And this is the way the B tree will be constructed. So now I am going to insert number 52. So while we comparing with the 55, 52 is lesser, come to the left hand side, then compare to 10, 52 is larger, go to the right hand side, then compare to 50, 52 is larger, go to the right hand side. So 10, 50, 52. So there is no sufficient memory to have to accommodate the 52. So now find the median value called as 50. So now the 50 will go to the parent node. So how to write 50? So according to the binary search tree order, 55, 50. So here 50 is lesser. So come to the left hand side and place the value called as 55 here. So first you have to focus on the bottom level node is called as a 50. So now the 50 will be taken as a root node, that means intermediate node, and the left hand side of 50 we have 10 and the right hand side of 50 we have 52, and then you have to focus on the 55. So in the 55 already we have 60 in the right hand side, so I have to write the 55 here. So in the right hand side we have to construct another node is called as 60. So this is a way, and this is a way the B tree will be constructed. So see here once again, first you have to focus on the insertion operation. While we inserting number 52, 52 is lesser than the 55, come to the downside, and the leaf node we have 10, 50s are there. So 10, 50, 52. So compare to 10, 50, 52, 50 is in the intermediate node because there is no space to insert the element in the leaf node. So 10, 50s are there. Now we have 10, 50 and 52. So 50 is the median one, so I have to take into the parent node because there is no space to insert it in the left hand side branch. So now the 50 will goes to the parent node. So while we going to the parent node, in the parent node we have one space is there, so we can able to accommodate the 50 here. So place the value 50 at first, then you have to have the left hand side branch and the right hand side value. So place accordingly. So left hand side we have 10 and the right hand side we have 52 as for 50, and the 55 we have the left hand side already we have 52 and the right hand side we have 60. So according to the binary search tree you have to insert the node from the root node to leaf node. If the leaf node does not have any space, then you have to do the rearrange, that means sorting order, then find the median value, then the intermediate value will be 5 goes to the parent node. Insert 20. How the 20 will be inserted? So first you have to compare with 50, 55. 20 is lesser, so come to the left hand side. In the left hand side, so in the left hand side we have 10 is there. So 10 is compared with the 20. So 10 is lesser. So the 20 will be placed, if the place is available, 20 will be placed in the right hand side of 10 and it will satisfy the binary condition also. And now I am going to insert number 30. So what will happen? So if the 30 will be compared with the 50 and 55, so 30 is lesser, so come to the left hand side. Then in the left hand side we have 10, 20 is there. So 10, 30 will be compared with the 10, 30 is larger. So then 30 will be compared with the 20, 30 is larger. So there is no space to accommodate the 30. So you have to write the values like 10, 20 and 30. So you have to rearrange in the ascending order form, then find the middle value, and middle value should goes to the parent place. So the 20 will be goes to the parent place. See here 20 will be compared with the 50. So 20 is lesser than 50 and 55. There is no space for inserting value 20 at the moment. So now find the median value and place the median value become the root value. So the 50 is going to become the root value. So because 50 is the median one. After that you have to write the value of 50 left hand side and the right hand side. The 50 left hand side we have the value called as 20 and the 50 right hand side 55. So here the value called as 55. So here in the 55 right hand side value called as 60 and the 55 the left hand side value called as 52. So according to this 20 we have 10 at the left hand side and 30 will be the right hand side. So here places 10 and here places 30, and this is the way the 30 will be inserted into the B tree. So now I am going to insert number 80. So where the 80 will be inserted? So the first you have to compare with the 50. So 80 is larger. So come to the right hand side. In the right hand side we have 55. And we have the memory space also. So 80 will be compared with the 55. 80 is larger. So come to the leaf node. So first whenever we are doing the insertion operation of B tree, you have to insert the node in the leaf node. If the leaf node does not contain any space, then you have to take the median value and then only you have to insert the 80 at the respective place. So we have to compare with 80 and 60. 80 is larger, so 80 will be placed here. And now I am going to insert number 90. So first you have to compare with the 50. 90 is larger, come to the right hand side. Compare to 55, 90 is larger, so come to the right hand side. So here we have the value like a 60, 80, and 90. Do the sorting operation. If it is sorted, leave it. While whenever we are doing the insertion operation, the tree will be get sorted by itself. So 60, 80 and 90. So here the 80 is going to become the intermediate one. So 80 will be forwarded to the parent node. If the parent node having any memory space, keep the 80 in the intermediate place. See here, this is 80 goes to the parent node. So here we have to place the 80s here at first. Then 80 left hand side we should have 60 and the right hand side we should have 90. So create another node. So create one another node and place the value called as 90 and create a link. So this is the way the 80 will be placed in the respective memory space. So once you doing the insertion operation in B tree, so first you have to focus on the leaf node. If the leaf node is full, you have to take the median value and find the median value. So before that you have to do the sorting operation. So once the key is sorted, then find the median one and take the median value to the intermediate node. If the intermediate node also full, now I like to see the example with 100. So now I am going to insert number 100. So how the 100 will be inserted? So first 100 will be compared with the 50. 100 is larger, so come to the right hand side of branch. And 100 is compared with the 55 and 80. So 100 is larger, so come to the right hand side. And here 90 is compared with the 100. So 90 is lesser, so it will be present the left hand side of 100. So this is the way the 100 is inserted. Now I am going to insert number 110. So how the 110 will be inserted? So in the existing tree, we have to place the value of 110. So how the 110 will be inserted? So here 110 will be compared with the 50. So 50 is lesser. So 110 will be come to the right hand side branch. So coming here and compare with the 55 and 80, 110 is larger. So come and check in the right hand side. And here 90, 100, 110 is there. So 90, 100, 110. So find the median value. We already knows that. So the median value should be go to the parent place. In the parent place we have 55, 80, 100. So here the memory space is also full. So then find the median value and place the median value into the root node. So in the root node, if the root node having memory space to accommodate the 80, so you can place it. See here, the 80 will be placed here at first. So after placing this value, 80's left hand side we have 55. Yes, the 80 left hand side we have 55 only. But the 80's right hand side we have 100. So create one another node. So create one another node and place the 100 here. And according to this 80's right hand side we have to make the 100. So once the 100 is placed, then come to the left hand side of branch. So here 100 left hand side we have 90, 100 right hand side we have 110. So according to the situation you have to write like this. So according to the situation, 100 left hand side we have 90 and the 100 right hand side we have 110. And this is the way the B tree will be executed. So whenever we do any insertion operation, first we have to compare with the root value. Our value is lesser than the root value, come to the left hand side, or else our value is greater than the root value, go to the right hand side. Then compare it and have to focus on the leaf node. So if the leaf node does not contain any children, if the leaf node does not contain any memory space to accommodate the new incoming node, and you have to rearrange the values and find the median value like this. Place the median value goes to the parent node and left hand side and right hand side should be as it is in the given node. The median node is going to the parent node. While the node is going to be the parent node must have memory space to accommodate the median node. And here if the memory space is not available, then again you have to do the same operation. Find the median value and place the median value into the parent node. So according to the situation, 80 goes to the parent place. So now I am going to insert the value 65. So where the 65 will be inserted? So 65 is compared with the 50. 65 is larger. So then again you have to compare with the 80. So 65 is lesser. So come to the left hand side, which means that this place you have to focus. That should be greater than 50 and less than 80. So here we are in the place of intermediate node and you have to compare with the 55. So 55 is lesser than the 65 or not. So 55 is lesser than the 65. Again it will comes to the right hand side. And here we have the space is called as 60 and here one more space is available, so we can place the 65 here. And now we are going to insert number 70. So how the 70 will be inserted? So first we have to compare with the 50 and 80. 70 is going to be inserted. So 50, 70 is larger, so compared to 80, 70 is lesser. So come to this place. And here 55, 70 is larger, so compared to this place. And here we have 60, 65 and 70. And now the situation 65 is the median one. So the median one will be placed to the parent node. If the parent node does not contain any space, you have to find the median one and place the value in the parent node. Then according to the situation 55 and the next space is available to accommodate the 65. So here according to the situation 65 will be placed here, and the 65 left hand side we have 60, yes of course, and the right hand side of 65 we need to place the value called as 70. So this is the way the B tree will be constructed. So while you searching any value in the B tree, so first you have to find the root node. So here root node value called as 50. Come to the left hand side. According to the binary search tree, so you have to focus on the leftmost node. So value called as 10. Then root node value called as 20. Then right side value called as 30. Then come to the root node is called as 50. So in the 50 there is right hand side is there. Come to the right hand side. So in this right hand side there is left is there. So 52. Then go to the root node is called as 55. Then go to the right hand side of 55 is called as 60. Then take the root node is called as 65. Then right hand side value called as 70. Then go to the parent node is called as 80. Then come to the right hand side there is left is there, so 90. Then root node is called as 100 and the right hand side called as 110. So this is the way the sorting operation as well as the searching operation will be takes place in the B tree. So this is the way we have to do the insertion as well as searching operation will be takes place in the B tree. So thank you for watching my channel. Thank you. In the forthcoming video I like to explain about the concept of B plus tree.